Hello everyone and welcome. Let's do some revision on Form 2 Mathematics. In this paper we shall go through various topics that are going to help us as we prepare for KCSE examinations. So question number 1, that is section 1, 50 marks. Evaluate without using tables or calculators. You have that and you're supposed to leave your answer in standard form. So without using tables or calculators. So in this question, as you proceed with your workings, you're not supposed to leave any room showing that you've used a calculator or mathematical tables. Everything should be done manually. So the first thing you're going to do, count the number of decimal places, both the numerator and the denominator. So when I look at these, the numerator has 1, 2, 3, 5 decimal places. Then the denominator has 4. So to remove all the decimal places here, we shall multiply these both the numerator and the denominator by 100,000. So this is what I'm going to do. So we shall have 0.19 times 0.032 divided by 200 times 0.0038. So I multiply the numerator by 100,000, which is the same as 10 raised to the power 5, and also the denominator. So for the numerator, once you multiply, all the decimal places will be removed. So you have 19 times 32. This is a 1, 2, 1, 2, then 1, 2, 3. 1, 2, 3. Then for the denominator, you have 1, 2, 3, 4. 1, 2, 3, 4. You see, be left with 10. So you have 200 times 38, then times 10. Then from there you can simplify. Just check what you can divide. For example, 19 divided by 19 is 1. 38 divided by 19 is 2. Then 2 divided by 2 is 1. 32 divided by 2 is 16. And then from there you have 16 divided by 2, 8. 100, these are 200 divided by 2, 100. So from there you now have in the numerator 1 times 8, you have 8. The denominator you have 100. These are 100 times 10, which will give 1000. So 8 divided by 1000, this one you'll get 1, 2, 3, then 1, 2, 3. So this one you have 0.008. So that is the answer. You're supposed to write that one, the answer, in standard form. So write 0.008 in standard form. You have 8 times 10 raised to power negative 3. Question 2. Question 2 is on fractions. Hassan earns every end of month, then spends his money as follows: a quarter on food, a sixth of the remainder on fare, a fifth of what remains on electricity and water bills, a half of what remains on rent, and saves the rest for emergencies and investments. If in May 2025 he saved 24,000 shillings, determine his total earnings for that month. So let's go to the first statement. The first one here, a quarter on food, a quarter on food. So for food, spends a quarter. Then a sixth of the remainder on fare. So fare will be a sixth of the remainder. How do we get the remainder? After spending a quarter on food, what remained? Assuming that the whole salary is 1 or 4 over 4. Then we subtract food. That is how we get the remainder. So assuming the whole salary is 1, or simply 4 divided by 4, then you subtract food. The remainder is 3/4. So fare is a sixth of the remainder, which is 3/4. So that is how we're supposed to work it out. And this one will give an eighth. So an eighth on fare. Then a fifth of what remains again on electricity and water bills. So electricity and water bills will be a fifth of, again, what remains. Now it is what remains after now spending on food and fare. So we need to get the fraction for food and fare, which is for food is a quarter plus fare, that is an eighth. So you add that. 1 over 4, there is a quarter, then plus, so quarter plus an eighth. Now that one gives a 3/8. So that is what is spent on food and fare. So what remains now? Again, we're assuming that the whole salary is 1. So now subtract the expenditure for food and fare, which is 3/8, to see what remains. So this will give 5/8. So therefore electricity will be a fifth of what remains. That is a fifth of 5/8. And this will give electricity and water bills to be 1/8. Then again, a half of what remains on rent. So again, we have rent. Rent is a half of what remains. Now it is what remains after now spending on food, fare, and electricity. So we need to get that sum. Food, a quarter, plus fare, an eighth. We got that on as 3/8. Then again from 3/8, then we add an eighth. Now we'll have added food plus fare plus electricity. That will be 3/8 plus an eighth, and this will give 4/8. And 4/8 is the same as a half. So now, having spent food, fare, electricity, that one translates to a half. So what remains? 1 subtract a half. So whatever remains is a half. So now rent will be half of what remains, and what remains is a half. And therefore rent will be a half of a half, which will be a quarter. And then saves the rest. Now we have the savings. What will be the saving? Whatever remains. Now to get what remains, we shall again take the sum of 1/4 for food, plus 1/8 plus 1/8 plus 1/8. So that is a food, a quarter, fare, an eighth, electricity, an eighth. Then we have rent, an eighth. So what fraction so far is this? So that is what you're supposed to do. So we add everything there. So for food and fare, we had got that on as 3/8. So we had got that on as 3/8. Then plus electricity, that is an eighth. So electricity, that is an eighth. And then rent, that is a quarter. That is a quarter. So now everything translates to 3/4. Everything here translates to 3/4. So that is the sum of what is spent so far. Food plus fare plus electricity plus rent is 3/4. So what remains is what goes to savings. So what remains, the whole salary is 1, subtract 3/4. This will be quarter. So a quarter is what remains. So savings will be quarter. Now, if in May 2025, he saved 24,000. So a savings, which is a quarter, this is equivalent to 24,000 shillings. Determine his total earnings. Assuming the total earnings is 4/4 or 1. So if a quarter is equals to 24,000 shillings, what about the whole salary, which is 1, equivalent to 1? So you simply cross multiply. So this will be 1 multiplied by 24,000 divided by a quarter. That is the same as multiply by 4/1. So this one will give 96,000 Kenyan shillings. Question 3. Convert 0.0108 into a fraction in the simplest form. So to convert this recurring decimal to fraction, you will let the fraction be. So let the fraction be r, say r, and this r is 0.01. Now you can see that the dots are on top of 1 and 8. So the number that should be recurring is 108. So 108 is recurring, 108, and so on. So that is equation 1. Then multiply this fraction r by 10. Explain how you do that. So when you multiply that fraction 0.0108 like that, we multiply that on by 10, you'll get 0.108. Remember, 108 is the one that is recurring. 108, 108, and so on. So there's something I want you to observe, that we are going to proceed by multiplying this fraction by multiples of 10 up until we shall come to a point where this decimal part is uniform. For example, look at that, 0.108, then look at the second one. So look at this one, not yet uniform. It is not uniform, not the same. So if not the same, what do? Continue. So we shall continue. Now we multiply by from 10r, now multiply by 100. Multiply by 100. So 100. Multiplying r by 100, you will have 1.08108. Don't forget that 108 is the one that is recurring. Again, when you look at equation 1, 2, and 3, and look at the decimal part, still we don't have any two equations that are similar from the decimal part. So you continue. Now multiply by 1,000. Take r and multiply by 1,000. So when you multiply by 1,000, you will get 10.8, then 108, 108. Don't forget that is the pattern. That is what is recurring, 108. So that is equation 4. Again, when you look at all these equations 1 to 4, up to that part, still we don't have any two equations whereby from the decimal point we have a similar thing. So you proceed from 1,000, now go to 10,000, multiply r by 10,000, and this one will give 108. This will give 108.108, 108, 108, and so on. That is equation 5. Now I've already spotted two equations that are similar from the decimal part, and I want you to look at this equation here. Look at this particular equation, this one, and then look at this. You can see the decimal part, 108, 108, 108, and so on. So in such a case now, you will take you're going to subtract equation 2. So subtract equation 2 from equation 5. This, so we're going to take 10,000 r minus, so you have 10,000 r minus 10r. So 10,000 r minus r is equals to, now when you look at the decimal part, that is 108.108, then subtract 0.108, so you remain with 108. So when you take 108, that is in equation 5, 0.108, 108, like that, subtract 0.108 and so on, you remain with 108. So 10,000 minus 1, or 10,000 r minus r, that will give 9,999 r, like that. Now this is minus 10. I forgot these, not minus r. This was supposed to be point of correction, please. Some point of correction. We're subtracting equation 2 from equation 5. So 10,000, this is a 10,000 r minus 10r. Sorry for that. 10,000 r minus 10r. This will give 9,990 r. When you subtract that, is equals to 108. Then from there, you remember the fraction, you let the fraction to be r. So you want to get r, divide both sides by 9,990. And this will give, when you divide these and simplify, you shall get, so 108 divided by 9, like that. This will give 2 divided by 85. 2 divided by 185. In the simplest form. Question 4. Determine the perimeter of the figure below, made up of a rectangle of length 50 centimeters and width 35 centimeters and 2 semicircles of its sides. So when you look at this figure here, it is made up of a rectangle. You can see the rectangle, and the length is 50. So let me indicate here. So this is 50 centimeters. So this one means this is 50 centimeters also. And then the width is 35. This is 35 centimeters, and this one is 35 centimeters. So the semicircles that you can see on the sides will have that diameter, which is 35 centimeters. Now to get the perimeter, perimeter is distance around, total distance around this figure, the total distance around. So we shall get the total distance around, we add like this from there, that is the distance. That is the distance around, like that. So that is what you are supposed to get. So I will get this distance here, the distance around these semicircles. So this distance that is here, is what I want to get first, and it will be the same distance with the other on the other side that is there, that distance. And to get that distance, that is the shape of half a circle, and the perimeter will be given by half pi d, because it is half a circle. So this will be a half times pi, which is 22/7, times the diameter is 35. So this one will give 55 centimeters. So this length here is 55 centimeters. So this is 55 centimeters. Now, after getting that, now we can get the total distance of the perimeter. So that will be given by 55 centimeters plus 50 centimeters plus 55 centimeters plus 50 centimeters. That is what is going to give the total distance around that figure. So this one will give so we have 55 times 2 plus it is 55 times 2 and then plus 100. So that is going to give 210 centimeters. Question 5. A trader bought 5 packets of Ringos and 4 packets of ice pops at a total cost of 120 shillings. She later bought 3 Ringos and 6 packets of ice pops and spent 126. Determine A. The cost of 1 packet of Ringos and 1 packet of, this one is packet, 1 packet of ice pop. So 5 packets of Ringos we can let the cost of 1 packet of Ringos to be represented by X shillings, and then we can let the cost of 1 packet of ice pops to be represented by Y shillings. So therefore 5 packets of Ringos will cost 5x, having the cost of 1 packet of Ringos to be X shillings, and then 4 packets of ice pops will be 4y, and that will give a sum of 120. So these will form simultaneous equations. Then she later bought 3 Ringos. I mean, something is missing here. 3 packets should be 3 packets of Ringos. 3 packets of Ringos. So this will be 3x. That will be the cost of 3 packets, because 1 packet costs X shillings. And then 6 packets of ice pops. 6 packets of ice pops will be 6 times y. 6 times y. And then that will give a total cost of 126. So having these 2 simultaneous equations, you can use any suitable method to solve that. And you're solving for X, which is the cost of 1 packet of Ringos, and Y, which is the cost of 1 packet of ice pop. So you can use elimination. I will eliminate X, 5x, 3x. I want to eliminate X, so I want to make the x's to be 15. So to make 5x to be 15, I have to multiply that one by 3. To make 3x to be 15x, I will multiply that one by 5. So the whole of the equation must be multiplied by that. And therefore, this will give 15x plus 4 times 3, this will give 12y is equals to 360. The second equation should be multiplied by 5. So this will give 15x plus, then this will give 30y is equals to 126 times 5. That will give 630. Now you can subtract to eliminate x. 12y subtract 30y is negative 18y. Then 360 subtract 630, that will give 270. So y therefore will give, divide both sides by, and this will give negative 270. So negatives will divide, so divide both sides by negative 18. 270 divided by 18, that will give 15. So that is y. Then to get x, you simply need to take one of the equations here. I will take 5x plus 4y is equals to 120, and then I substitute 5x plus 4, y is 15. You just substitute that, and this will give 120. So 5x plus 60 is equals to 120. 5x will give 60. Take this on to the other side, so x will be 12. So therefore, you have the cost. Remember, x was the cost of one packet of Ringos. So for Ringos, one packet of Ringos will be x, that is 12 shillings. Then for ice pops, it will be 15 shillings. So we go to part B. The total cost of buying 6 packets of Ringos and 10 pieces of ice pops is supposed to be packets. Sorry for this typing error. It's supposed to be the total cost of buying 6 packets of Ringos and 10 packets of ice pops. So since we have the cost of one packet of Ringos to be 12, so 6 packets of Ringos will be 6 times 12. That. Then 10 packets of ice pops. One packet of ice pop is 15 shillings. So 10 packets will be 10 times 15, like that. So this will give 72 plus 150. So 72 plus, so this one is going to give 72 plus 150. You'll get 222 shillings. Question 6. A regular polygon is such that the sum of its interior angles is 1440 degrees. Determine A, the number of sides in the polygon, and B, the size of each exterior angle of the polygon. So you're given the polygon and the sum of the interior angles is 1440. So how do you get the interior angles of any regular polygon? We get it by this formula, 2n minus 4 right angles. So that is how we get the sum of interior angles of any regular polygon with n sides. N here represent the number of sides. So this one is equivalent to, assuming that represents the sum of the interior angles of a regular polygon with n sides, it should be equivalent to 1440. So when you multiply everything here by the bracket by 90, you get 180n minus 360 is equals to 1440, like that. So from here you can make n the subject. You can add 360 to both sides, so you get 180n is equals to 1440 plus 360. This will give 180n is equals to 1800. So n, you divide both sides by 180, you get n is equals to 10. So this polygon has 10 sides. Part B, the size of each exterior angle of the polygon. Again, how do we get the exterior angle? One exterior angle of a regular polygon. We get it by this formula, 360 divided by n. That is how we get the size of each exterior angle in a regular polygon. So in this case, we have 360. You divide by the number of sides, which is 10, and this will give the size of each exterior angle to be 36 degrees. Question 7. A racing car left Naivasha starting point at 07:28 hours and raced through the set track for 6 hours 12 minutes, took a tire change break for 18 minutes, and proceeded for 3 hours 27 minutes to Mount Kenya. At what time did it arrive at Mount Kenya point? Give your answer in 12-hour system, that is clock system. So this is a question testing on whether you are capable of adding time and calculating questions involving time. So the journey started at 07:28. So 07:28 hours. This is the same as 7:28 a.m. Then it raced through the set track for 6 hours 12 minutes. So we add 6 hours 12 minutes. So when we add that, you'll get this is 0, this is a 40, and then this one is 3, and this is 1, that is 1340. Then from there, took a tire change for 18 minutes. You add 18 minutes, that. So this will be 8, this will be 5, this will be 3, this will be 1, 1358. Then from there, proceeded for 3 hours, 27 minutes to Mount Kenya. So 3 hours, we add 3 hours and 27 minutes, like that. So this will give 5. Then 5 plus 2 plus 1, that will give 8. So 85 minutes, that is first 1 hour. So when you subtract 85, subtract 60, that is 1 hour, you get 25. Remember, you have exceeded, you have to carry 1 hour there. So you have 13 plus 3, that is 16, then plus 1 hour, that will be 17. So now this is the time. So 17:25 is the time they arrived at Mount Kenya. So 17:25 hours. So 17:25 hours in 12-hour clock system, you simply subtract 12 hours. This will give 5:25 p.m. Question 8. Factorize and simplify. Now, to work out this question, we shall express the numerator and the denominator in terms of the product of the prime factors. So you take the numerator, we express the numerator, that is 1728. So you have 1728. We express this one as a product of each prime factors. You do that. So we start by dividing this number by 2. So when you divide it by 2, 1728. So 1728 by 2, you get 864. You divide 864 by 2, you get 432. Divide by 2 again. Divide 432 by 2, you get 216. 216 divided by 2, you get 108. 108 divided by 2, you get 54. 54 by 2, you get 27. Then from there, you divide 27 by 3, you get 9. 9 by 3, you get 3. 3 by 3, you get 1. So 1728 as a product of each prime factors will be 2 by 2 by 2. How many times? 1, 2, 3, 4, 5, 6 by 2 by 2 by 2. 6 times. By 3 by 3 by 3. That is 3 times. Now we are getting the cube root. We are getting the cube root of the whole of these numbers. So you're getting the cube root of these. You're getting the cube root. And so to get the cube root, this is what we do. We group these terms in pairs of 3. And for every pair of 3, you pick 1. That is how we get the cube root. We group these, so you can see, for example, there we have the pair of 3, you pick 1. Then for this one again, you pick 1. And then for this one, again, you pick 1. So that is how you get the cube root. You express that number in terms of the product of its prime factors. Then for every, you group them into 3 pairs of 3, like we've done. For every pair of 3, you pick 1. So this gives the solution as 2 by 2, that is 4. Then 4 multiplied by 3 is 12. So that is the cube root of the numerator. Now we go to the denominator. For the denominator, we have 22,500, and we'll do the same. We express this one in terms of the product of its prime factors. So again, we start by 2. So 22,500, we divide that one by 2, we get 11,250. Again, you divide that one by 2, you get 5625. Then from 5625, you can't divide that one by 2, so you divide it by 3, you'll get so 5625 divided by 3, you get 1875. You divide it again by 3, you get 625, like that. 625, you can't divide that one by 3, so you now divide by 5. So by 5, 625 divided by 5, 625 divided by 5, you get 125. Then 225 by 5, you get 25. Then by 5, you get 5. Then by 5, you get 1. So therefore, 22,500 in terms of the product of its prime factors will be 2 by 2 by 3 by 3 by 5 by 5 by 5 by 5. Now we are getting the square root. So what do you do when you're getting the square root? Now you group these terms in pairs of 2. In pairs of 2. So for this pair, these pairs of 2, that one again, that one, that one. For every pair of 2, pick 1. So 2 by 3 by 5 by 5. That is how you get the square root. For every pair of 2, pick 1. So this will be 2 by 3 by 5 by 5. So that one will give 150. 150. So that is for the denominator. Now let's go and get now the solution. For the numerator, we got 12. For the denominator, 150. So we can simplify this. 12 divided by 3, we get 4. 150 divided by 3, we get 50. This is by 2 2, get 2 by 2, you get 25. So this one will simplify to 2 divided by 25. Question 9. Use tables of squares and reciprocals to evaluate. So you're supposed to use the tables of squares and reciprocals to solve this question. So I'll start with this part. 1 divided by 0.002854. For that one, you're going to use the tables of reciprocals. So let us use the tables of reciprocals together. So the first thing, you write this number in standard form, the denominator, since you can't find directly the reciprocal of that number. So this is how you're going to write it. So 1 divided by, so 0.002854 in standard form will be 2.854 times 10 raised to power negative 3. You can split this one and write it as 1 divided by 2.854 times 1 divided by 10 raised to power negative 3. See the same thing. Then from the tables of reciprocals, you read the reciprocal of 2.854. You need to be very keen. For the tables of reciprocals, at the end there, you're supposed to subtract, not to add. So let us read from the tables of reciprocals, the reciprocal of 2.85 up to that point, 2.85, you'll get 0.3509. That is up to 2.85. Then you're left with 4. So it goes straight, direct where 4 is. And the number you're supposed to subtract there is 5. So you subtract 5, you get 0.3504. So that is the reciprocal of that. So 0.3504. Then the reciprocal of 10 raised to power negative 3, the reciprocal of that is 10 cubed. So now once we work out these, 0.3504 times 10 cubed, 10 cubed is 1000. This will give 350.4. So we leave it at that point. So that is the first part. Now we go to the second part, that is the square. So the square of 18.97. So again, cannot read this one directly from the tables of squares. So you write this one in standard form. So 1.897 times 10. And then remember you're getting the square of everything. So it is 1.897 squared and 10 squared. So from the table, read the square of 1.897. That will give, you read it up to 1.89. 1.89. That will give 3.572. And then you go straight to 7, column of 7. Then you drop down. The number that you're supposed to add is 26. So you have 26. This will give 8.953. So you get 3. This will be 3.598. And then 10 squared, that is 100. So when you multiply these, you get 359.8. So now you have the solution, you have these, subtract these. So now for the answer, you'll take 350.4, subtract 359.8, like that. So on this one is supposed to give negative. So 350.4 subtract 359.8. This is going to give negative 9.4 as the solution. Question 10. So for m in the equation, so this is a question on indices. So look at the terms and see whether you can be able to express all the terms to the same base. So when I look at the left hand side, it is possible to express the left hand side to the base of 2. And this is how you're going to do it. So for 4 raised to power 3m plus 4, 4 can be written as 2 squared. And then you have the power there, 3m plus 4. Then divided by 8 can be written as 2 cubed. Then you have m subtract 5 is equals to. Now for the right hand side, again, 16 can be written to the base of 2 as 2 raised to power 4. Then multiply by 32. 32 can be written to the base of 2. 32 is the same as 2 to power 5. And then you have the power 4m minus 7. So let us open the brackets. So we have 2. This will give 6m plus 8 divided by 2. 3m minus 15 is equals to, This is 2 raised to the power 4 times 2. Then you have 20m subtract 35. After doing that, now we can apply the laws of indices. Like the left hand side, that is a division. So when you're dividing this on the left hand side, you can express that one to the same base using the law of division of indices. You can see the bases are the same, so we need to subtract the powers. So the bases are the same, we subtract the powers. So that is 2, that will give 2. 6m plus 8, the whole of that. It is very important to indicate the brackets there. You subtract the powers, so we subtract 3m minus 15. Very important to indicate the brackets there. Is equals to, now for the right hand side, the law of multiplication. When you're multiplying and the bases are the same, you simply add the powers. Remember these laws. I'll write them here. When you're given, let's say, am divided by an, so this one can be written as a, you subtract the powers. If you have am raised to the power m times a raised to the power n, here you have a, then you add the powers m plus n. That is what I'm using here. So the right hand side, you have 2, then you have 4 plus you add the powers 20m minus 35. So from there, you notice that the bases are the same from both ends. So what you can do here is simply pick. You can pick the powers. You can pick those powers since the bases are the same. So I'll pick the powers like I've indicated there. So pick the powers, that is 6. Sorry. So I'll pick the powers, that is 6m plus 8. When you open this bracket, you'll have negative 3m. Then negative, when you open this with negative 15, you get negative multiplied by negative, you get positive 15 is equals to 4 plus 20m minus 35. Now what you need to do here is simply collect the like terms, put them together, or collect all the terms containing m and put them on the left hand side. And then without m, the terms, constant terms without m, I'll take them to the right hand side. So this is what I'll have: 6m minus 3m. Then from the other side, I subtract positive 20m from both sides. I'll get 20m, negative 20m. And then on the right hand side, I'll have 4 subtract 35. I take positive 8 to the other side, I get negative 8. Positive 15, take it to the other side, I get negative 15. So now you have 6m minus 3m, that is 3m. 3m minus 20m, you get negative 17m is equals to, so this one you have 4 subtract 35, subtract 8, subtract 15. This one gives negative 54. Negative 54. So from here, you simply get m by dividing both sides by negative 17. So you get m is equals to negative 54 divided by 17. Simple as that. And because you have negative on both sides, of course you'll have a positive answer there. So 54 divided by 3 divided 54 divided by 17, you'll have 3 point. So m, you can write m in terms of decimal or fraction. So this will give 3.176 as the solution. Question 11. Use tables of logarithms to evaluate. So there is a question. So we use the tables of logarithms to do this. So I will prepare a table here. So showing the number. Then you shall have the column for the standard form. And then the logarithm like that. So that is the table. So the first one is 477.9. So write this one in standard form. This will be 4.779 times 10 raised to the power 2. So now we shall get the logarithm from the table. The logarithm of 4.779. You read that. You read the logarithm of that. And then the logarithm of 10 squared. 10 raised to the power 2. The logarithm of 10 raised to the power 2, we start with that, is 2. Then the logarithm of 4.779 will be 0.676793, like that. Then it is being multiplied by 2.2 2.076. Writing this one in standard form to be 2.076 times 10 raised to the power 0. So logarithm of 10 raised to the power 0 is 0. Logarithm of 2.0 over 2.076, that will be 0.3172. So since you're multiplying these two numbers, 477.9 and 2.076, you add their logarithms. So when you add these, you get 5 is 16, you get 9, and then here you get 9, and this one is 2. So that is what you get, and that is the solution for the numerator. Now we can go to the denominator. So now we go to the denominator where we have 38.26. Write this one in standard form. You get 3.826 times 10 raised to the power 1. The logarithm of 10 raised to the power 1 is 1. Then read this one from the table. Remember, we're using the tables of logarithm for all these. So logarithm of 3.826, that will be 0.5827, like that. Being multiplied by 11.99, logarithm of this is 1.199 times 10 raised to the power 1. Logarithm of 10 raised to the power 1 is 1. Then logarithm of 1.199, that will be 0.0788, like that. Again, you're multiplying these two numbers, so you add their logarithms. This will be 15, this will be 11, this will be 16, this will be 6, and this will be 2. That is the solution for the denominator. So now the next thing that you're going to do is now take the solution from the numerator, which is here, and then the denominator is here. So we take numerator 2.9965. You're dividing the whole of that by the denominator, which is 2.6615. So when you're dividing numbers, you subtract their logarithms. So this will be 0, this will be 5, this will be 3, this one will be 3, then this one will be 0. All right. So from there now, after dividing, now we have this solution. We have this, the final solution. We have multiplied, we have divided. Now one more thing is remaining. When you look at the question, we are required to get the square root of the whole of that. So now getting the square root, we are going to divide the logarithm by 2. So 0.3350, we divide that one by 2. When you're getting the square root, you divide that number by 2. So 0.3350, you divide that one by 2, you get 0.1675. That is what you get. Now it's time to get the answer. Now that you have obtained the square root, now to get the answer, you get the antilog of this number. So to get the antilog of 0, that is the characteristic, is 10 raised to the power 0. Then the antilog of 0.16, so you get the antilog of that. The antilog of 0. From the table, 1675, like that. And this will give 1.4771. This is what you get, 1.471. So from there, when you multiply these, you get the solution as 1.471, and that is the solution. Question 12. Two similar cuboids have surface areas of 90 centimeters squared and 160 centimeters squared, respectively. Determine the volume of the smaller one if the larger one has a volume of 960 centimeters cubed. This is a question on similarity, and you can see you're given two similar cuboids. You're given their surface areas. So the surface area of the first one is 90 and 160. From that, we can manage to get the area scale factor. This is the ratio of the areas of two similar figures. That is area scale factor. So we shall get the area scale factor by simply taking 90 centimeters squared, that is the smaller, divided by the larger one, which is 160 centimeters cubed. That is how we get the ratio. So we can write this one in simplest form. So this will be 90. So 90 divided by 100. I want to simplify this, give it as a fraction. This will give 9:16. That is the simplest form. So 9 divided by 16, which we can write it as 9:16. So this is the area scale factor. Now for us to get the volume, because the volume of the smaller one, we need to get the volume scale factor. And before we get the volume scale factor, we'll be required to obtain linear scale factor. Linear scale factor, that is the ratio of the lengths of two similar figures. So there is a relationship between area scale factor and linear scale factor. So to get a linear scale factor, you get the square root of the area scale factor. So that is what you're going to use. So linear scale factor, therefore, is given by the area scale factor, which is 9 divided by 16, and then you get the square root of that, and this will give 3 divided by 4. That is the linear scale factor. After getting linear scale factor, now that will help us to get the volume scale factor, and volume scale factor is what is going to assist us to get the volume of the smaller one. So linear scale factor, or in simple terms, volume scale factor, is given by linear scale factor cubed. So therefore, volume scale factor will be given by linear scale factor, which is 3 divided by 4. Then we get the cube of that, and this will give the volume scale factor as 3 cubed is 27 divided by 4 cubed, that will be 64. Give 64. So that is the volume scale factor. This will assist us now to get the volume of the smaller cuboid. So remember, this ratio, which is the volume scale factor 27 divided by 64, we used the smaller cuboid on the numerator, then divided by the bigger cuboid in the denominator. So therefore, this will be the volume of the smaller cuboid divided by the volume of the bigger cuboid. So this will give 27 divided by 64 is equals to, we can let the volume of the smaller cuboid to be x because we don't know it. Then the bigger or the larger one is 960. Now using these, you can simply cross multiply. You get 64 times x, you get 64x is equals to 27 times 960. So x therefore will be 27 times 960 divided by 64. So we work out these. So 27 multiplied by 960, then divided by 64. So this will give 405 centimeters cubed. Question 13. So for x, given that sine of 2x subtract 10 is equals to cosine of 3x plus 30. So in order to solve this question, there's a concept that we need to know, and this is the concept that given sine of angle A is equals to cosine of angle B, or you can be given the cosine of angle A is equals to sine of angle B, then A and B should be complementary. A and B should be complementary. They should add up to 90 degrees. So now when you look at this particular question here, you have sine of 2x subtract 10 is equals to cosine of 3x plus 30 degrees. So when you look at this one keenly, you can see you're going to use this property. The whole of this angle, you can let the whole of this angle to be A and the whole of this angle to be B. And therefore, using the property above, you'll get 2x subtract 10 plus B, which is 3x plus 30. That should give us 90 degrees. So work out these. This will give a 5x plus 20 is equals to 90 degrees. And 5x will be 70 degrees. So x will therefore be given by 14. X will be given by 14. So that is the value of x, 14. Question 14. Calculate the area in hectares of a triangle measuring 180 meters by 220 meters and 140 meters. So this is a triangle and you're given the 3 sides. Just have a rough sketch of that triangle. So the measurements are given as 180 meters, 220 meters and 140 meters. So how do you get the area of a triangle given the 3 sides? It is by simply using the hero's formula. So area will be given by the hero's formula, S minus A, S minus B, S minus C. That is the hero's formula. And then you get the square root of these. Just make a line here. So again, to doing that, you get the square root of that, where S is the sum, is the average of the sum of the 3 sides. We let this side to be A, this side to be B, this one to be C. So S will be given by 180 plus B, which is 220, plus C, which is 140, divided by 2. That is how we get S. S is the average, of the 3 sides. That is how we get S. So when you work out the value of S, you will get, using a calculator, this will give 540 divided by 2, and this will give 270. Now we use the formula. So area is given by S, which is 270, then 270 minus A, 180, 270 minus B, which is 220, then 270 minus 140, like that. You get the square root of that. So this will give 270 times 270 minus 180, that will give 90. Then multiply by 270 subtract 220, that is 50. 270 subtract 140, that will be 130. Then you get the square root of that. So once you multiply the whole of these, 270 by 90 by 50 by 130, that will give 157,950,000. You get the square root of that. When you get the square root of that, it will give 12,567.8 meters squared. So that is what you get. Now after getting the area in meters squared, you need to get the area in hectares from the question. So you need to convert now the meter squared to hectares. Remember, 1 hectare is equivalent to 10,000 meters squared. So what about 12,567.8 meters squared? How many hectares will be that? So we simply divide. So we simply get this one by dividing. So area will be obtained by, we take 12,567.8, divide that by 10,000. We divide that by 10,000, and this will give, the answer is 1.2568 hectares. Question 15. Calculate the area of a regular hexagon whose sides measure 12 centimeters. So let me begin by sketching. I can sketch this hexagon, 6-sided figure. No, this is just a sketch. 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. So that is a hexagon. And assuming the center is there, when you form triangles, you'll end up with 6 similar triangles. 6 similar triangles, and the lengths are given. The length is 12. So this is a regular one, so 12, like that. Now, having done that, there's something that is going to help us here to get the area, and we need to get the angle, each angle here, because all these angles are similar, these angles are equal, and there are 6. We are going to take 360, that is the angle at a point, the angles around that particular point, angle in a circle. This one, divide this one by 6, because there are 6 angles. Each of these angles is the same, they are equal. So when you take 360 divided by 6, you get 60. That means each of these angles, this is 60. Each one of them is 60, like that, 60, 60. So I can extract one triangle, and that is what I'm going to use to calculate the area. So now look at that triangle, and we have this angle here. This angle is 60. This side is equal to this, and then this side is 12. So if I drop a perpendicular bisector there, this will be 6, and then this angle here will be 30, and this one will be 30. So I can manage to get the hypotenuse. I can get the hypotenuse by simply using the trig ratios. So I'll use either of these right angle triangle. So I can use this one that is here. So to get this, I can use sine. Yeah, I can use sine. Sine of 30 degrees is equals to the opposite side, which is 6, divided by the hypotenuse. That. So if you now find sine 30 is equals to 6 divided by h, if you make h the subject by cross multiplying sine 30 times h, you get h sine 30 is equals to 6 times 1, that is 6. And from there, you will have h dividing both sides by sine 30. H is equals to 6 divided by sine 30. And this will give, I was changing the mode of my calculator. So that will give 12. And now having the hypotenuse, that means all these sides that are here, the sides that I've been able to obtain are these sides. These are 12. All these are the sides that I've obtained, 12, 12, 12. With that, I'll be able to get, so this is 12 and this one is 12. So having that, I'll be able to get the area of that triangle, and then I'll multiply it by 6 because there are 6 similar triangles that make this regular hexagon. So I get the area of this one triangle, and which formula am I going to use? Area is equals to a half AB sine theta, because I have two sides, that is 12 and 12. So a half times 12 times 12, and then times sine of 60. Sine of 60. That is the angle between these two given sides. That will be the area of one triangle. Now to get the entire hexagon made up of 6 such triangles, I multiply by 6. And this now will give the area of the whole of these hexagon. So this will give by 2 and by 2, 6. So I have to multiply 6 by 12 by sine of 60 times 6, sine of 60 times 6, like that. And this will give 374.113, that is centimeters squared. Question 16. The diagram below shows a square pyramid with base sides 3 centimeters each. The slant heights are each 3 centimeters long. Draw the net of the diagram. There we have the figure. Is a square-based pyramid, and the square is 3 centimeters. That's the sides. The slant heights are also given as 3 centimeters long. You are supposed to draw the net accurately. It should be drawn to scale, not as a sketch. So the first thing you're going to do, as you've seen there, is to have the base, that square base. You are opening this square-based pyramid up. You're opening it. That is how you draw the net. And you start by drawing accurately the base, that is a square of 3 centimeters each. So this is a square, and it should be accurate with 3 centimeters, 3 centimeters, 3 centimeters, 3 centimeters. Now once you draw that square, and ensure that you measure that using a ruler, you're drawing that. Now we need to have the slant heights. The slant heights are equal. They are all 3 centimeters. So you're going to stand with your pair of compass, having taken measurement of 3 centimeters. I'll take 3 centimeters. So 3 centimeters is up to that point. So that is 3 centimeters. Let me drag these. So that is 3 centimeters I already have. So just demonstrating. So you take this one from the ruler. Sure, you take this one from the ruler. So having taken 3 centimeters from the ruler using a pair of compass, stand at these corners and then mark arcs. So you mark an arc there. So let me mark smaller ones here. So from there, you mark an arc there. Then with the same radius, you stand on this corner here and then cut that arc like that. Then the other corner, all the corners, you have to do this from all the corners. So from this corner again, mark an arc there with the same measurement, 3 centimeters. Do the same that. Then cut that arc. On the other corner, mark an arc there. Then stand on this arc again, this corner, and then cut that arc like that. Then on the other side, like that. So once you've made those arcs, Now you join all these points, join these corners to the point of intersection like that using a ruler. Join the corners to the point of intersection of the arcs like that. And the last one is here. That is how you draw the net. Notice that all these sides are equal. All these sides, the slant heights are equal, and they are all 3 centimeters. So that is how you draw the net of that square-based pyramid. Section 2. Question 17, Part A. A German tourist arrived in Kenya with 8950 euros, which he converted to Kenya shillings using the rates below. He spent a total of 842,300 when in Kenya. He converted the balance to UAE dirhams before leaving for Dubai. How much money to the nearest dirhams did he have before he left Kenya? So the table is there for euros and UAE dirhams, both buying and selling. So the first question, how much money was he left with before he left Kenya? So we start by converting. He arrived in Kenya with 8950 euros. So we need to convert that one first to Kenya shillings. So we're converting foreign money to Kenyan money. And for that case, we buy. So anytime we're converting foreign to Kenyan money, we buy. So to convert 8950 euros to Kenya shillings, this is what you're going to do. So we have this column here for buying. So 1 euro is equivalent to, read to this, 1 euro is equivalent to, or it buys at 169.20 cents. So what about 8,950 euros? So you cross multiply, this will give 8950 times 169.20, and this will give the amount in Kenya shillings, which is 1,514,340. So that is the amount of money he arrived with in Kenya shillings. So he spent a total of 842,300. So from this amount, we subtract 842,000 to see how much he was left with, 300. So we subtract, and when you subtract this one, you find that he remained with, this will be 672,040. So that is the amount. Now then, he converted the balance. Now that this is the balance, so this is the balance he was left with, and he converted this balance to UAE dirhams. So now we are converting, in this case now we are converting the Kenyan money to foreign money. So therefore we are going to sell. So we're going to use the sell column. So this is what you're going to use. So 1 UAE dirham sells at Kenyan shillings 33 and 80 cents. So what about this balance, which is 672 and 40? So what about that? So we cross multiply, this will be 672,040 multiplied by 1 divided by 33 and 80 cents. So this will give us the amount in dirhams. So when you multiply this one and divide, you're going to get 1988.84. Now the question is, you're supposed to give this one to the nearest dirhams. So this one to the nearest dirhams will give 19,882. Because we have 0.8, we round this one forward, we get 883. So 19,883 UAE dirhams. So that is the solution. Go to the next part. Caleb sells jeans trousers and he receives 21,780 as a monthly salary plus a commission of 9% on sales he makes above 20,000 shillings. Each jeans trousers he sells at 750 shillings. Calculate 1. His total earnings when he sells 50 pairs of trousers. So there's two things here. So there's a monthly salary and then there's a commission of 9%, but this one is only of goods above 20,000. So let's go to the sales that he made. So that month he made sales of 50 pairs of trousers. So for this one, one pair is 750. What about 50 pairs? So this will be 750 shillings times the 50 pairs. So this one gives 37,500. So that is the earnings from the sale. Now for the commission, he gets commission of 9% for sales above 20,000. So let's see sales. What are the sales above 20,000? So he made sales of 37,500. So sales above 20,000, you simply takes 37,500 and then subtract 20,000, and this will give 17,500. So this will be the amount that will be subjected to the commission. So the commission will be calculated using this amount. This is the amount that is above 20,000. So therefore, for the commission is 9% of the sales above 20,000, which is 17,500. That, and when you work out these, you will get an amount of 1575 shillings. So this is the commission. And then we have the salary. So you have the salary. Now to get the total earnings, now the total earnings will be given by, we have the monthly salary, which is 21,780 plus the commission, which is 1575. So that is what is going to give the total earnings. And this one will give an amount of 23,355. Part 2. The number of pairs of trousers he sold in July if his total earnings was 28,080. So you're given the total earnings and you are required to calculate the number of pairs of trousers. Now, these total earnings, 28,080, is inclusive of the monthly salary plus the commission. So therefore, we need first to know the commission. So to get the commission, we take this amount, which is 28,080, because this amount is inclusive of the salary and the commission. So when you take that amount and you subtract the monthly salary, which is 21,780, this will give the commission. So we get the commission as 6,300. Then how is this commission arrived at? How do you arrive this commission? You arrive to this commission by getting 9% of goods above 20,000. So this commission, you get it by, so this commission, which is 6,300, you get it by working 9% of the goods that are above, or the sales that are above 20,000. Now we don't know that amount, so we can let the total sales be represented by X. That is the total sales. So therefore, the sales that will be above 20,000 will be obtained by, you take the total sales, X, and then you subtract 20,000. That is when you get the sales that are above 20,000. So that is how you get the commission. So 9% of the sales above 20,000, and we've let the total sales to be X. So now when you get X will now represent the total sales, and therefore we work out this X. So X will be what? So we can start by multiplying. Both sides of the equation by the reciprocal of 9 over 100. So that you get X subtract 20,000 like that, and is equals to 6,300 times the reciprocal. You actually multiplying both sides by 100 divided by 9 like that. So this will give X subtract 20,000 is equals to, when you multiply these, and this will give 1 by 9, this will be 700. So this will give 70,000. You get 70,000. So the total sales will therefore be 70,000 plus 20,000, and this will be 90,000. Total sales. X is total sales, 90,000. So now after getting the total sales, remember these sales were made from the trousers, and we know that one pair of trousers costs 750. So what about the whole of this amount? What about these total sales? That is 90,000. How many pairs of trousers were sold in order to get 90,000? So we simply take 90,000, divide by 750, and this will give 120 pairs. Question 18. Omolo, Mbohe, and Kabue started a business by contributing a total of 360,000 in the ratio 378 respectively. At the end of the year, they made a total profit of 288,000, which they agreed to share as follows: 20% to be put back in the business, 25% to be used for buying a new computer, the balance to be shared in the ratio of their first contribution. Determine how much each contributed initially. You're supposed to determine how much each contributed initially. Now the total contribution was 360,000 and it was contributed in the ratio. So you have Omolo, Mbohe, and Kabue in the ratio 3:7:8. So first of all, we need to get what fraction each of them contributed. So if it is Omolo, for example, Omolo will be 3 over divided by the total. You get the sum of the ratios. So the sum of the ratio will be 3 plus 7 plus 8, which will be 18. So Omolo's fraction will be 3 divided by the total ratio 18, and then for Mbohe will be 7 divided by 18, and then Kabue will be 8 divided by 18. So that is the fraction contributed by each. So now we go to the contribution, how much each contributed. So Omolo contributed 3 divided by 18 of this amount, 360,000. So find this amount will be 60,000. Then for Mbohe, so for Mbohe it will be 7 over 18 multiplied by 360,000. So this will give 140,000. And then for Kabue it will be 8 over the total multiplied by 360,000. So this will be 160,000. So that is the amount contributed by each. We go to part B, the amount put back in the business. We given the percentage. The amount put back in the business here is 25%. Is it 20%? 20% was put back to business. So 20% of the total. So the amount put back to business, let me see. So the profit, that is the profit. So at the end of the year, they made a profit of 288, which they agreed to. So it is a profit, 20% of the profit. So 20% of the profit was put back to business, and that is the profit is 288,000. So this will be 20%, 288,000, and this will give 57,600. Then part C, the cost of the new computer purchased. Cost of the new computer purchased. That one is 25% of the profit. So 25% of that. So 25% times the total profit 288, and this one will give 72,000. Then the other part D, how much each received from the profit made. After using the 20% back into the business, then 25% to be used for buying a new computer, the balance was shared. So you need to get this balance. So now the amount, so balance will be obtained by taking the total profit, then subtract 20%, which was put back to business, which is 57,600 from the previous part we've done, and then the cost of this computer, 72,000. This is what is going to give us the balance. So work out the balance, 288,000 subtract 57,600 plus 72,000. So the balance was 158,400. That is the balance, and this is what will be shared in the ratio of their contribution. So now how much each of them received. If this one was to be shared in the ratio of the contribution, remember the ratio is 3:7:8. 3:7:8. So 3:7:8. This is Omolo, this is Mbohe, and this is Kapui. So for Omolo, it will be 3. The fraction was 3. We got this times the amount to be shared, which is 158,400. So Omolo will get 26,400. Then we have Mbohe. It will be 7/18 multiplied by 158,400, and these will give 61,600. And then the last one, Kabue, was 8 divided by 18 times 158,400, and these will give 70,400. So that is how you're supposed to work out that question. Question 19. 4 towns P, Q, R, and S are such that Q is 460 kilometers from P at a bearing of 080 degrees. R is 400 kilometers on a bearing of 150 degrees from Q, and S is 350 kilometers due south of P. Part A. Use a scale of 1 centimeter represents 100 kilometers. Show the positions of the 4 towns. 5 marks. Now the best way to study this question is by drawing a sketch. Let's draw a sketch of what you have. So we have 4 towns. So we start with the first one here. Q is 460. Q is 460 kilometers from P. So you shall draw the north. Shall construct the north. So the north here, 080. Remember, for true bearing, we measure true bearing from the north in a clockwise direction. So this point here, this is where we have P, and the center here, that is where we have P. And then 080, you measure it in that direction. So that is 080 degrees. And this distance is 460 kilometers. So Q is somewhere here. So Q is somewhere here. So that is where we have Q. So now that is the first part. Q is 460 kilometers from P on a bearing of 080. That is what we have represented. Then R is 400 kilometers on a bearing of 150 from Q. So 150 degrees from Q. So from Q again, you shall draw the north here. You shall construct the north, and then that. So 150 degrees will be somewhere there. So this is the angle. This is how you're going to measure the angle. So this angle here, that is a 150. So remember that was Q. So R will be somewhere there. And the distance, R is 400 kilometers. 400 kilometers on a bearing of 150 from Q. That is what you have represented. Then S is 350 kilometers due south of P. So due south of P, we shall only extend what we have here. Shall only extend this one. Due south means directly south. So it will be somewhere there. So that is where we shall have S. So S will be there. Due south of P, directly south. So you just need to extend that line. And this is the distance is 350 kilometers. So after drawing that sketch, this is what you're going to use now to draw accurately. And you'll need a pair of compass. Actually, you need a ruler and a protractor for this. So having the scale 1 centimeter represents 100. You're given 1 centimeter represent 100 kilometers. So meaning for all these measurements, we divide by 100. So for 460, we divide that by 100, you shall have 4.6 centimeters there. This one you shall have 4 centimeters. And this one you shall have 3.5 centimeters. So now we can go to the accurate drawing. So when you're drawing the north, when you're constructing the north, kindly ensure that these angles here are right angled. That is the first thing you're supposed to do. Ensure that when every time you're constructing these, you ensure that this angle is 90 degrees when you're constructing your north. So we have P. P is here in the center here. That is where I have P. So we measure 080 degrees. So 080. So place your protractor there. So 080. So 080. Let me place it like this. The best way to place this one, can place it that way. The best way you can measure these like that. So 080 from the center here. So you can see 080 will be there. 80 will be there. You can see from here we have 10, 20 up to 80. So that is 80 degrees. So this is the angle 0, 80 degrees. Then from there we need to take a measurement of 4.6 centimeters. You can see that from the sketch there, 4.6. So that is 4.6. So with 4.6 you stand at P and you mark an arc there. So that is where we shall have the position of Q. So the position of Q will be there. So from there, the next thing, so this is the distance. So this is the distance, 460 kilometers. So from there, we now need to draw another node at Q. You're following this sketch here. So I'm constructing a node there. So that I have 90 degrees at that point. So that is why I'm using a protractor to do this. So now having that, let me show that this is 90 degrees. So you can see that is 90 degrees. So made sure that I've constructed a node there, and you can see this is exactly 90 degrees. So at Q. So after doing that, I need now to measure. So this is the node. So now I need to measure 150 degrees from there. Remember, we're following the sketch that is here at Q, 150. So 150. This is how I measure 150. And you check how I'm placing my protractor. So 150 degrees. So 150 degrees is to that point. So that is 150 degrees. So that is 150. So you can see, just confirm these. So these are measured. So from here you have 10, 20 all the way to 150. So that is 150. So with that now, so this is on 150 degrees. Now we need to take a distance of, from the sketch, a distance of 4 centimeters. That is 400 kilometers. So you stand at Q, pair of compass, and then you need 4 centimeters. That is 4 centimeters, and then you mark. So these will be 400. These will be 400 kilometers, equivalent to 4 centimeters. So now this will be the position from the sketch. This will be the position of R. That will be the position of R. So what is remaining now is position of S, which is 350 kilometers due south of P. So we stand at P. We extend that line southwards. Due south means directly south. That will be 3.5 centimeters. 3.5 centimeters. So you just need to extend these. Extend using a red. So like that. And then you take a measurement of 3.5. So 3.5 from standing at P, you have a measurement of 3.5. That is 3.5. So you mark, that is 3.5. So that is S. And this is 3.5, which is equivalent to 350 kilometers. Now, you have now indicated all the positions of P, Q. So you have P is there, Q is there, R is there, and S is there. Now we go to the questions. Now. The questions are here. So the first question, use the diagram above to determine 1, the distance and the bearing of S from R. SR. So you need to get this distance SR. So SR, so you can join this point S using a straight line to R like that, and you take that distance. So I'll use a pair of compass here. Mine is calibrated, or you can use a ruler in your case. So I want to get the measurement for that. So this will give, so this is giving 6.6. Is giving 6.6 centimeters. So that is a 6.6 centimeters. Now remember, since you are supposed to give it in kilometers, not actually in centimeters, but it's supposed to be given in kilometers. So I've obtained 6.6 centimeters. So to convert this, remember the scale is given there. 1 centimeter represents 100 kilometers. So multiply this one by 100, and this will give 660 kilometers. So the other thing we need to give is the bearing. The bearing of S from R. the bearing of S from R. So S from R. So what you need to do is simply constructing north at R. So now to construct the north at R, of course, to ensure that that angle is 90 degrees, let me use a pair of compass here. So I want to place it at that point at R, the central point be there, like that. And then I will, so from that point down, like that. So this is north. So after doing that, the angle that you need to measure after constructing the north at R, ensure that this is 90 degrees. You're supposed to give the bearing of R. Go to the question. You're supposed to give the bearing of S from R. S from R. So from R, this is where you're going to measure the angle. So you measure the angle, this angle from the north clockwise. So the angle that you require is the entire, so that is the angle that you need. That is the angle that you need to measure. So what you need to do to get that angle, you can measure the remaining angle that is left there, or you can simply get 180, because from this point up to this point, that is 180, and then you add this that is here. So let me measure. I want to measure the angle that is here. I want to measure this angle. So now I can see this is this is how I measure the angle. So you can see measuring the angle from here. The central part is the, so from this direction 10, 20, 30. This is around 82. This is around 82. So that angle is around 82. So you're measuring it from this point. So that is around 82. So this angle here is 82 degrees. So therefore you shall get now this whole of this angle, which is 180 plus 82 to get the solution. So 180 plus 82 degrees, and that will give true bearing, which is 262 degrees. So that is the bearing. The other question, part 2, the distance of P from R. The distance of P from R. The distance of P from R. So again, you can join PR. So P to R, P to R, using a straight line. And then you get that distance. So you can use a ruler. In my case, using a protractor, it is calibrated. You must be very keen when you're placing your. So mine is giving 7.1. 7, it's actually 7, exactly 7. You can see from the diagram, exactly 7 centimeters. So that is giving exactly 7 centimeters. 7 centimeters, which of course you multiply by 100, this will be 700 kilometers. So that is 7 centimeters. Then you multiply by 100, you must give the answer in kilometers, that is 700 kilometers. The other question, the distance of Q from S. The distance of Q from S. Q from S. So Q is here, then S is here. So again, you can join that using a straight line, QS, and then you measure the distance. So mine is giving 6 point, let me confirm they have placed in, so 6.3, getting 6.3. So that distance is 6.3 centimeters, 6.3 centimeters. They multiply that by 100, and this will give 63. This is a 630 kilometers. For these measurements, a slighter allowance is always given of plus or minus 0.1 in all these measurements. So don't worry about the slight difference that you get. A slighter allowance is always given. So that is how you're supposed to solve that question on bearing. Question 20. Use a ruler and a pair of compasses only. Part A, construct a parallelogram EFGH such that EF is equals to 5.2 centimeters, EH is equals to 6.3 centimeters, and angle EFG is equals to 120 degrees. That is 4 marks. So I will start by drawing the baseline. The baseline, I will use that one as 5.2 centimeters. And remember, you're supposed to use a ruler and a pair of compasses only in this question. No protractor is required. So let me draw the baseline. The baseline is, draw the baseline here. That is the baseline as EF. I need EF be located anywhere. So let me mark. So this is where we shall have E. So I need EF 5.2. So take a measurement of 5.2. So I'll take the measurement using the pair of compass there. So take 5.2. So 5.2 is there. So with the measurement of 5.2, stand at E, and then from there you mark an arc. like that. So this is how we shall have F. So this is 5.2 centimeters. Now look at this angle. You need to construct an angle EFG. So the angle at F to be 120. So to get 120, I'll construct 60. And when I construct 60, on the other side, I'll be left with 120. So the side, this is the side where I want to construct 60. I want to construct 60 degrees to the right side of F. So this is how you construct an angle of 60. So standing at F, you mark an arc, that big arc, then with the same radius without changing it. First of all, you have to extend this arc. So let me extend this arc. So let me repeat that again. Sorry. So I want to construct an angle of 60 degrees at F. So standing at F, you mark an arc, big arc there. Can mark a big arc there. And then with the same radius without changing it, stand on this point here, that point, and then cut that arc like that. So when you join this point, the point F, the point of intersection of those arcs, that will be 60 degrees. So now you have 60 degrees here. So this is 60 degrees, and automatically the one that will be left on the other side will be 120, and that is how you construct it. So 120. Why? Because this is a straight line, and the sum of angles on a straight line should be 180. So now, having constructed that, there's something else that will help you to complete this parallelogram. You have EH. EH is should be somewhere here, but you need to know the angle that will be here. So if this angle is 60, automatically the other angle here. So having this line, we just explain, having this straight line down, and then you have E, and then you have F there, and then we have constructed this one as 60. So that means the other angle that will be here, I have this one must be 60 as well, because EF is acting as a transversal, and these two lines are parallel to one another. So if I have 60 degrees on this side, I should have 60 degrees on the other side. Those angles are corresponding. So I should have an angle of 60 at E, and that will help complete that parallelogram. So again, I will construct 60. I'll construct 60 at E. So standing at E, in a suitable radius of your choice, suitable radius, and construct 60. So and construct an angle of 60. So mark an arc there, big arc, and then the same radius, you cut that arc. So I have to draw a big arc here. So I have to go back again here, ensure the arc that I made here, that arc. So you make a big arc there, like that. And then we've done this, we stood here, in this arc, and then cut that arc. So that is a 60 degrees. So that is 60 degrees. So if you join, now if you join this one, there is a point from E to the point of intersection of those arcs. That will be 60 degrees. So you can see this angle that is here, this angle must be corresponding with this, because this is a transversal. This is a transversal. So in a parallelogram, if this angle is 60, this one must be 60. So it must be corresponding, because these are pairs of parallel lines. These pairs parallel lines, and this one is acting as a transversal. So now it's time to get EH. EH should be 6.3 centimeters. 6.3 centimeters. So you just take measurement of 6.3. So 6.3. So standing at E. So I want to take my pair of compass is calibrated. It is showing the measurement. So 6.3 is there. So that is measurement of 6.3. Mark an arc with that. So this point that we've marked here, this point is now H. That point is H. And you know very well that these sides, EH, now what you're missing is G. Again, on the other side, you're supposed to ensure you mark the same on the other side. So on the other side, so you stand at F with the same measurement of 6.3. That will give G. remember the properties of a parallelogram. Opposite sides are equal and parallel. So EH should be equal to FG. So this is a 6.3 centimeters and this one should be 6.3 centimeters. Now you just need to join H to G using a straight line. H to G, you join that using a straight line like that. And the parallelogram is complete. So this side is equal and parallel to the other side. So this is a 5.2 centimeters. Now it is complete now. All the measurements are there. The angles are accurately drawn. This is not where we've used a protractor, just a ruler and a pair of compasses. So from there we go to the other question. Measure the length of the diagonal. Measure the length of the diagonal of the parallelogram EG and GH. EG and GH. EG and GH. So let me join. I join EG. So EG is there. We measure that. EG. So let me take that measurement. So that measurement is 10 centimeters. That is giving 10 centimeters. So that is 10 centimeters. And then the other one is GH. GH is 5.2. That one is equivalent to EF. EF is equals to GH, that is 5.2. So we can fill that. So EG 10 centimeters and then GH is equals to 5.2 centimeters. Part C, draw perpendicular from point H to meet line EF at K. Drop perpendicular from point H. Draw perpendicular from point H. You can see point H, where point H is. So this is a point H to meet EF. At K. So this is what you do. This is how you drop perpendicular. So take your pair of compasses and stand at H. That is where you're supposed to drop perpendicular from, like that. Supposed to drop it from there. Then make sure you mark two arcs. You mark two arcs on this line, even if it is extended line EF. Standing at H, mark two arcs on line EF. Sometimes you will need to extend EF in order to mark those two arcs. So now I mark those are two arcs. Then you stand on these two arcs, so that point that you've made, and then mark them with the same radius. The other point where the arc cuts that line EF, cut that arc like that. And then from there, simply draw a straight line from H to the point of intersection of the two arcs. So from H to this point. So this is how we have dropped perpendicular from H. Standing at H, you mark an arc there, down there. Then you stand on this point, you mark an arc. Then you stand on this point, you mark another arc. Then you join the straight line. So from H to the point of intersection of these arcs. So this point where it meets, this perpendicular meets EF, that is K. This point K. So point K is here. So that is point K. So now we've done that. Next question is calculate the area of the parallelogram using HK as the perpendicular height and EF as the base. So we get the measurement of HK, that is perpendicular distance. Let us get that measurement. So I'll take that measurement. So that measurement is 5.4. See, that is 5.4 centimeters. So this is 5.4 and the base is EF. So now getting the area, how do you get the area of a parallelogram? The area is given by the base times the perpendicular height. The base is 5.2 centimeters and then the perpendicular height. The perpendicular height is 5.4 centimeters. So that is what you're supposed to multiply out. When you multiply, you get 28.08 centimeters squared. Question 21. A triangle ABC has vertices A, 1, -1, B, 3, -1, and C, 3, -3. Part A, ABC undergoes a reflection in the line x is equals to 0 to form A prime, B prime, C prime. Draw the two triangles on the same graph. So that is the first question. You're supposed to draw the two graphs at the two triangles. Now this is what you're going to do. I'm not going to use this grid that is here because it is distorted because of scanning. The paper has been scanned. Allow me to use this one that is here to plot everything. So we have the triangle A, 1, -1. So 1, -1 will be here. 1, -1 is here. So 1, -1 is there. Then we go to the next. The next is B, 3, -1. 3, -1 is here. 3, -1 is here. So that is B. So B is here, 3, -1. And then C. And then C is 3, -3. 3, -3 is here. So 3, -3, that is 3, -3. So it is here. Now you can join the object. So you have A to B using straight lines, then from B to C, and then A. So that is triangle ABC. We go to now from the question, that triangle undergoes a reflection in the line x is equals to 0. X is equals to 0. So x is equals to 0. Which kind of line is this? X is equals to 0 is the line y-axis. So the y-axis is the line of reflection. X is equals to 0 is the equation of the y-axis. So the y-axis will be the mirror line. So we need to get the image of each of these points, A, B, and C. So we start with A. You know the properties of reflection. The distance between the object and the mirror line should be equal with the distance between the mirror line and the image. And in a reflection, the object points and the image points are directly opposite each other. So look at A and then the distance to the mirror line. Now in this case, the mirror line is down the y-axis. So you can see there is only one square to the mirror line. So the image of A will be here, will be reflected here. So this point here, though, it will be, so it will be here. So that will be A prime. So A prime, you can see just one square to the mirror line. So from the mirror line, count one square, it will be there. Then for B, the distance between B and the mirror line, how many squares? Those are 3 squares. So from the mirror line along that straight line, because they must be directly opposite each other, so count 1, 2, 3. So it will be here. So that is where we have B. So this is B prime. So B is there, B prime is there. So you can see the distance between B and the mirror line, 3 squares. Then from the mirror line to the image, 3 squares. They are directly opposite each other. For C, again, how many squares are these? 1, 2, 3 to the mirror line. So from the mirror line, you have 1, 2, 3. So it will be here. So that will be C prime. So C prime will be here. And now you can join these points. You can join them. So join them like that using formula. And there we go. So now you have solved the first part of the question. That is a reflection in the line x is equals to 0. So you have the image of ABC and a reflection in that line x is equals to 0. The next question down there, state the coordinates of A prime, B prime, C prime. The coordinates. So what are the coordinates? What are the coordinates? So the coordinates A prime is -1, -1. That is how you write the coordinates. B prime is -3, -1. Then C prime is -3, -3. So A prime -1, -1. B prime -3, -1. C prime -3, -3. So we've answered that question. Now we go to part C. A prime, B prime, C prime is rotated through -90 above the origin to form A double prime, B double prime, C double prime. Draw A double prime, B double prime, C double prime on the same graph. So now we go to the other question. So this triangle is rotated through -90 degrees. -90 degrees we shall measure, and the center of rotation is the origin, that is 0, 0. So for negative rotation, we are going to measure this angle in a clockwise direction. So this is what you're going to do. You're going to rotate each point at a time, and this is how we rotate each point through the origin. So we start with the first one. So the first one is A prime. So to rotate A prime, join point A to the center of rotation. that is A, like that, join it. And then from there, you measure. So we're going to measure. So we measure 90 degrees, measure 90 degrees in a clockwise direction. So once you have joined A prime to the origin, you've seen using a straight line, a ruler, you measure 90 degrees, and that is clockwise direction. So this is what you're supposed to do. So you take your protractor and then you rotate it. So you place it like that along that straight line that you've drawn, like that. Along that line that you have drawn, that is straight line from A prime to the origin, and then measure 90 degrees. You measure 90 degrees like that. That is 90 degrees. So let me place this on properly. It's supposed to be 90. If not, somewhere I need to adjust here. Supposed to be like that exactly. So you measure 90 degrees. You can see that is 90 degrees. So you can see the way I've placed it. So place it along that straight line, and then you measure 90 degrees in a clockwise direction. In a clockwise direction, you can see from this point, from the object point that is A prime, clockwise direction like that. That is how I measured 90 degrees. So you can see this is the direction. That is the direction. Let me indicate it properly. So that is the direction you're supposed to measure. That is how anti-clockwise direction means. So you can see that direction. So that is not anti-clockwise, but clockwise direction. From A, you can see how I am moving clockwise direction. That is how you measure that angle. Now, after that, now the next thing you're going to do, now that you've measured 90, that is what you're supposed to do for all the points. So you have that as 90 degrees. Now the next thing is to take this distance. Take the distance A to the origin. Look at that distance from A to the origin. Then transfer that distance from the origin. It will be somewhere there. So it must be equidistance. So from A prime to the origin, from the origin, that the same distance. So you notice that this is where we shall have A prime. That distance must be the same. So A prime to the origin, transfer that distance. That is 1 square, 1 square. So you're going to do the same for B prime. So be very fast in this one. So join, so B prime to the origin, and then you measure 90 degrees. You measure 90 degrees, measure 90 degrees. So you place that one along that straight line you've drawn from B like that. That is how you're supposed to do it. And then draw a straight line. So this is 90. That is the line. So you can see this angle. This is the line you've drawn from B prime to the origin. Measure 90 degrees in a clockwise direction. So you can notice that this is a 90 degree. This is the angle that is formed. So now after doing that, you take the distance again. Take this distance B. You have B prime. You can use you can even count how many squares are these from B prime to the origin. That distance you can see 1, 2, 3. Those are 3 squares. 1, 2, 3. Then from the origin, count 3 squares. 1, 2, 3. So B prime will be here. B that is B double prime. The other one was A double prime. The previous one was A double prime. Then B double prime will be there. I repeat that. So look at the distance from B prime to the origin. How many squares are these? 1, 2, 3. So from the origin, 1, 2, 3. So that distance must be same. So this distance from B prime to the origin, then from the origin to B double prime, the same. Do the same for C. Do the same for C. So join C to the origin. Find that is a straight line like that. And then you count this distance. You notice that the angle that we had measured for after joining A to the origin, that is the same straight line that we have here. So this is the line. So 90 degrees is going to be formed here. So when you measure 90 degrees using this line, C prime to the origin, so 90 degrees will be there to form that line there. So now count how many squares are here from here. This is 1, 2, 3. So from the origin, 1, 2, 3 along this line. So that is where we shall have C. C will be there. C exactly. Let me check just to confirm. Yeah, that is why it will be. It will be there. So C double prime. So C double prime. This is a C double prime, it will be there. Confirming that distance, so this is the distance. So from C prime to the origin, those are 3 squares, 1, 2, 3. Then from the origin here you have 1, 2, 3, so it will be there. So now you can join these points. You can join these points. Let me join them. So using a straight line, so join, that is the triangle. So that is the triangle. So now we have rotated that triangle. We have rotated it through -90 about the origin being the center. We go to part D. Part D, A triple prime, B triple prime, C triple prime is formed when A double prime, B double prime, C double prime is enlarged about 0, 0, that is the origin, and the scale factor +2. Draw this image and state its coordinates. So this triangle that we've drawn here, A double prime, B double prime, this triangle, you're supposed to enlarge that through the center as the origin and scale factor +2. Now for positive enlargement, both the object and the image are on the same side with the center of enlargement. For negative enlargement, the object and the image are on opposite sides of the center of enlargement. That is very important to note. So in this case, you shall have the center is here. You draw a straight line joining A and then you extend it. So that is what I'm going to do. So straight line from A and then you extend it. That line is already there. Extend it like that. Then once you do that, you take this, you're enlarging it by 2. So now you take this distance from here. You can use a pair of compass for this. So stand at the origin and then the distance to A prime, that distance to A prime is just 1 square. So because we're enlarging it by 2, that is enlargement by 1. So from the center to where A double prime is, that is enlargement by 1. So to enlarge it twice, you just move the second time. So it will be there. I repeat. So from the origin to where A double prime is, that is enlargement by 1. So you go the same distance. You can use a pair of compass to do this. You move another 1 step, that is enlargement by 2 times or by 2. So it will be there. So this is where we shall have A triple prime. Now for C double prime, we want to enlarge that by 2. So again, you join C double prime to the center of enlargement. I've drawn that line, then you extend it like that. So from the origin, they're sharing both A double prime and C double prime are sharing the same line here. So now to enlarge that, take that distance from the origin to C double prime. Count how many squares are those. Those are 1, 2, 3. The 3 squares, that is enlargement by 1. So you add other 3 squares. You count other 3 squares from C double prime. So 1, 2, 3. So this is where the image of C double prime will be. So it will be here. So it will be there. So C. So it will be there. C triple prime to be there. I repeat that. So from the origin O, so up to where we have C double prime, those are 3 squares, that is enlargement by 1. So you count other 3 squares from there, 1, 2, 3, get the image there. So for B, do the same. So from the origin to B double prime, those are 1, 2, 3 squares. So those are 3 squares. So from there again, you count 3 squares, 1, 2, 3. So it will be here. That distance must be doubled. So you can see from O to where B double prime is, those are 3 squares, that is enlargement by 1. You count other 3 squares from there, 1, 2, 3. So it will be there. So this is exactly where we shall have B triple prime, like that. So from there, you simply just need to join. You just join this one using a straight, with the straight line or ruler. So there is A, and there you have it. So there you have the triangle. So A triple prime is there, B triple prime is there, and then C triple prime is there. So you've done that part. So now the next thing is to draw the image. You've done that and state the coordinates. So the coordinates are as follows. A triple prime will be -2, 2. Then B triple prime will be -2, 6. And then C triple prime will be -6, 6. So that is how you're supposed to solve that question. Question 22. A straight line L1 has an equation 2y plus 3x is equals to 12. Part A, find the x and the y intercepts of line 1. The x and the y intercepts of line 1. So we start with the x-intercept. So the x-intercept. So one thing that you're supposed to know is that at x-intercept, the y-coordinate is equivalent to 0. At x-intercept, y-coordinate is equivalent to 0. So you're going to take this equation and substitute y with 0. And when you do that, you will get 3x is equals to 12. So the x-intercept will be 4. So x is equals to 4. Then now the y-intercept, at y-intercept, the x-coordinate is equivalent to 0. So just take the same equation and substitute x with 0. So 2y plus 3x is equals to 12. When you substitute x with 0, you shall have 2y is equals to 12. And y will be given by 6. So that is the y-intercept. We go to part B. Another line L2 is perpendicular to it at B, -2, -4. Determine the gradient of L2. That is 1. Gradient of L2. So when two lines are perpendicular, you know that the product of their gradients, let's say the first line has gradient M1 and the second line has gradient M2. When you multiply the gradients of two lines that are perpendicular, you get that product to be -1. So we need to get the gradient of L1, and the equation of L1 is 2y plus 3x is equals to 12. So to get the gradient, you have to write this equation in the form y is equals to mx plus c. So you shall have 2y is equals to -3x plus 12. So dividing both sides by 2, you get y is equals to -3 over 2x plus 6. So now we can identify the gradient, that is m1. So from this equation, m1 is the coefficient of, the gradient is the coefficient of x, which is -3 over 2. And since we've said when two lines are perpendicular, the products of their gradient is -1. So m2 now will be the gradient of L2. And what are we going to multiply by? That is -3 over 2 to get 1. It will be the reciprocal of that, which is 2/3, which is positive reciprocal of that. So m2 will be 2 over 3. And you notice when you multiply the 2, m1 times m2, you get -1. So that is how you go about that. So the gradient of that line 2 is 2/3. Part 2, the equation of L2. The equation of L2. Now that we have the gradient of L2, the gradient of L2 is given as 2/3, and it passes from part B, it passes through point B, which is -2, -4. We need now to use this gradient and that point to get the equation of that line. So what do? We can introduce another general point on that line, xy, and then we use xy and this point B to get the gradient. So gradient, which is 2/3 of this line, is given by the change in y subtract -4 divided by the change in x subtract -2. This will give 2/3 is equals to y plus 4 divided by x plus 2. So when you cross multiply, and this one you get, this is a 3 multiplied by y plus 4 is equals to 2x plus 2. So this will give 3y plus 12 is equals to 2x plus 4. So 3y is equals to 2x minus 8, and then you divide both sides by every term by 3. You get y is equals to 2/3 x minus 8 over 3. So that is the equation of L2. We go to part C. So for part C, another line L3 is parallel to line 1 and passes through 3, 5. That is a point. Determine the equation of L3. So L3 is parallel to L1. So when two lines are parallel to one another, their gradients are equal. So the gradient of L3 here should be equal to the gradient of L1 since they are parallel. So what was the gradient of L1? The gradient of L1 was, where did we get this? It was -3 over 2. It was negative 3 over 2. The gradient of L1, we got it here. It was here, negative 3 over 2. So that should be the same, the gradient of this L3 should be the gradient. So gradient is equals to negative 3 over 2. And this one passes through 0.35. So this again is very easy, because now we have the gradient of L3, which is equivalent to the gradient of L1, which is equals to negative 3 over 2. And there's a point where the line passes 3,5. So we simply introduce another general point, xy, and we use these 2 points to get the gradient. So gradient, which is negative 3 over 2, is equals to change in y subtract 5 divided by the change in x subtract 3. So we cross multiply. We have 2 multiplied by y minus 5 is equals to negative 3 x subtract 3. So this will give 2y minus 10 is equals to negative 3x plus 9. So 2y is equals to negative 3x, then plus 19, like that. So divide both sides by 2. Y is equals to negative 3 over 2x plus 19 divided by 2. So that is the equation. Or you can write it as y is equals to negative 3 over 2x plus 19 over 2. You can decide to write that one is as mixed fraction, 9.5. Still okay. Even for the previous one, you can still write this one as y is equals to 2/3 x. Then 8 over 3 will be 2 and 2/3. Still okay to write it like that. Now the other one, part D, determine the coordinates of x and y intercepts of line 3. So line 3, the equation of line 3 is y is equals to negative 3 over 2x plus 19 over 2. So the x and the y intercept, so we start at x intercept. Say that x intercept, the y coordinate is 0. So simply substitute y with 0 in that equation of line 3, and you will get 0 is equals to negative 3 over 2x plus 19 over 2, which will give 3 over 2x is equals to 19 over 2. So x is equals to 19 over 2 times 2/3. And this gives x as 19 over 3. 19 over 3. Or you can leave this one as a 6 and a third. So that is the x-intercept. So what about y-intercept? So at y-intercept, x coordinate is equals to 0. So take the same equation and substitute x with 0. So you have y is equals to 19 over 2. 19 over 2. Before we proceed, we're supposed to give the coordinates of the x and y-intercept. So for the first part, that is the x-intercept, we got the x-intercept to be 6 and a third. We said that at the x-intercept, the y-coordinate is 0. So therefore, the coordinate here will be 6 and a third, and the y-coordinate is 0. So that is how you're supposed to leave the coordinates of the x-intercept. So for the y-intercept, after we substitute x with 0, we get y-intercept to be 19 over 2. Remember, the x-coordinate is 0, so that point or the coordinate of the y-intercept will be x is 0 at y-intercept, and then y will be 19 over 2. Or 0, 19 over 2 is the same as 9.5. So that is how you're supposed to solve that question. Question 23. The diagram below represents two intersecting circles with centers A and B of radius 6.3 centimeters and 7 centimeters respectively. The angles subtended by the sectors are 84 degrees at A and 126 degrees at B. So the diagram is there. Determine A, the length of the line CD. The line, that is the length of the line CD. So this is what you're going to do to get that. So look at CD. And like you to consider this triangle here. Look at this triangle. So I will name this point here. We name this one as M. That a point of intersection. So there is this point of intersection. The point of intersection of these line AB and CD. So we use this triangle here because we have the radi. This is 6.3. This is a 6.3. This is 7, and this is 7. So this is a right angle triangle, the right angle triangle, And we can use that one. Since we have the angle subtended at the center is 84, and therefore these will be 42. This angle will be 42. So if I extract that triangle here, to look like this. So you have M, and then we have the hypotenuse will be 6.3, and then we have this angle here as 42. This 42. So what we want to get, so this is A, and then this one is C. So we want to get MC, and I will note that one by X, and it's the same distance with the other one there. So to get MC, I will use trigonometric ratios. So I will use sine. So sine of 42 degrees is given by the opposite side, which is MC, divided by the hypotenuse, which is 6.3. So therefore, MC will be given by 6.3 sine of 42 degrees. And this will give, MC will give, when you multiply these, you will get, using a calculator, you'll get 4.215 centimeters. So that is this length from C to M, and the same distance is equal to M to D. So now to get the whole of this distance CD, we shall just multiply that one by 2. So CD therefore will be 4.215 multiplied by 2, and this gives 8.430 centimeters. We go to part B, the area of the sector center A. The area of the sector center A. So how do you get the area of the sector? By theta over 360 pi r squared. So in this case we have this, the circle with center A. The angle at the center is 84 divided by 360 times the pi times the radius squared, 6.3 times 6.3. Just use a calculator, and this will give, when you use a calculator, this one will give 29.106 centimeters squared. We go to the next question. The area of the sector with center B. Remember, the angle on the other side is 126. So the area will be given by theta, which is 126, divided by 360 times pi times 7 times 7, that is the radius squared. And this will give 53.9 centimeters squared. Part D, the total area of the triangles ACD and BCD. Triangles ACD and BCD. So we have these two triangles here. We start with ACD. So we have the radius and the radius. Those are two sides and an included angle. We have an angle there. So the formula we are going to use is this formula. Area is equals to half AB sine theta, because you have two sides and an angle between, included angle. So we start with ACD. So for ACD we'll have half times 6.3 times 6.3 times sine of the angle between, which is 84 degrees. So this will give 19.736 centimeters squared. Then the other triangle BCD, we have a half times radius times the sine of 126. This will give 19.82 centimeters squared. So what about the total area? The total area now will be given by, we add the 2. So we take 19.736 plus 19.82, and this will give 39.556 centimeters squared. So that is the total area of the two triangles, simply using that formula, half AB sine theta. Now the shaded region, the last question, the shaded region, the area of the shaded region. So how do you get the area of the shaded region? When you get the total area of the sectors, that we calculated, that is the total area of the sector with center A, and then the other one with center B. There are several ways of doing this. You can decide to calculate the areas of the sector separately, then you subtract the area of the triangle. So when you look at this question, if you want to get for example, on this side where we have center A, so if you want to get the area of the shaded region, you'll get the area of the sector, then subtract the area of the triangle. The area of the sector and the area of subtract the area of the triangle. The same thing will happen on the other side. So on the other side, you shall do the same. This is 7, this is 7. So the shaded area is there. So to get the shaded area, you get the area of the sector, subtract the area of the triangle. Now, since we have already calculated the total area of the two sectors with center A and with center B, we now get the total area of the sectors. So total area of the sectors, that is with center A and with center B, we got that one to be 29.106 in part B, and the other one was 53.9. So we got that one as 29.106 and 53.9. So that is what we got, and this will give 83.006 centimeters squared. So total area of the sectors, then we subtract the total area of the triangles, which we have obtained in part D. So subtract total area of the triangles, and the total area of the triangles was 39.556. So we get that difference, and this will give 43.45 centimeters squared. So that is simply how we get the area of the shaded region. You get the total area of the sectors, then subtract the total area of the triangles.